Good afternoon, Math 142 online. Good to see you. Hope you're having a good start with the first couple of readings. You should have gotten a message from me. It's in WAMAP. If you don't get email notifications of a new message, I would really recommend you enable those. I will not email you a whole lot. But I do plan to just take a peek at each of you and see how you're doing and send you a message, just giving you a thumbs up or saying, hey, it looks like maybe you're falling a little behind, or just is everything going okay? The goal is just to keep you consistent in the class and chipping away at it. You'll see when it comes to the halfway point, you'll be able to maybe catch up on some missed assignments, but after we take our first exam, there's going to be no going back to the chapters 5 and chapter 6 in the book. So just make sure you're checking your emails from me. I won't send too many. Hopefully you got something out of hearing from me earlier today. I'm going to share my screen. I don't have too many things I want to talk about today, but the number one thing I want to talk about is to make a plug. And I actually didn't know last time I made this video that these were in here. But if you open any reading, they start with a PDF of the textbook. I don't really see why you'd ever open these. If you like a paper textbook and you bought a paper textbook and you can write in it, I see why you would like that. But as far as opening a digital version, this whole reading is a digital version of the same textbook. So with links and videos and animations, I really think it's if you're already working on a computer, just working through the reading is preferable to the PDF. However, this slideshow is really something extra. And a colleague of mine named Steve Kangas made these during the pandemic and really did a wonderful job clicking through. This is a Google Slide document, and just kind of, it's, in a way, it's both its tone and its rhythm with you deciding when to click forward is very, very nice. If I were a student in this class, I would definitely start with these. It will make the readings a little redundant, like you'll talk about the same ideas twice, but you can really go quickly through the reading, and if you've already gone through this slideshow. So I'm not going to go through this whole slideshow. I'm just making a plug to point that these are here. Steve did a really good job writing these up and thinking about how to present all this information. Getting into here why the 45, 30, and 60-degree triangles are kind of the main players, really based on the fact that we can solve for those lengths here, but it requires calculus to get the results that you see on your calculator when you do like the sine of 15.8 degrees. That actually relies on calculus to come up with those numbers. And since it's a pre-calculus class, you can't learn calculus to learn how some of this came about. Anyway, just making a plug for these. He has some really nice ways about going about this. As far as classes go, I know at least a couple of you really were hoping to be in the in-person class with that support of seeing one another. Just going to show you something that we're going to do tomorrow. Remember, we've only met twice in person. We met last Wednesday and then yesterday. So there's really only been one class, if you don't count that sort of, here's the syllabus, here's how this class works, here's how you log into WAMAP. We only met once yesterday, and we spent most of the time just taking questions and answering questions. And you all have the forum for that. If that's not working, I sent you the tutoring links. You can also schedule meetings with me if that stuff's not working. But just to show you something that I'm doing today, or going to do tomorrow in class, let me just do a new share. So this is like the agenda that I'm building for tomorrow's class, but I wanted to show you this. Then I'm going to hand out this empty version of the unit circle kind of, and I'm going to give them about 5 minutes to say, fill out as much of this as you can based on memory or figuring things out. And then I'm going to give some tips about how to go about this. For example, that if you know that a half circle is just a length of pi, and when we say that, the length of this arc, assuming radius of 1, then that's just going to be a length of pi. Then if we look at the 45-degree angle, that's really splitting up into fourths, right? We can say 1, 2, 3, 4. And if we wanted to keep going, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. which when you reduce those fractions become like pi over 2, pi over 4, 5 pi over 4, all those. But it's kind of easier to just think 1, 2, 3, 4, 5, 6, 7, 8 45-degree rotations will bring you to a full circle, or in radian form, that would be pi divided by 4, 2 pi divided by 4, 3 pi divided by 4, 4 pi divided by 4, and so on. Similarly, if you think of the other angles as sixths, if you notice, ignoring the 45 degrees, this is broken up into 1, 2, 3, 4, 5, 6 equal parts, each of 30 degrees. 180 divided by 6 is 30. So you could think of this, these are, the numbers kind of are confusing when you look at them, like pi over 6, pi over 3, pi over 2, and so on. It's kind of easier to just think, oh, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And then only some of those reduce, like 5 pi over 6 is what it's shown here, but 4 pi over 6 is going to show as 2 pi over 3, which is just to reduce fractions. Continuing that, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6 is going to equal 2 pi. Just a nice way to, like, you know, sometimes I look at and I just say, oh, find the 5 pi over 4 angle. And I might be like, where's that? What exactly is that? And it helps me just go, oh, that's like 10 pi over 4. So that would be 1, 2, 3, 4. 5 pi over 4 would not be 10 pi over 4. It would be 5 pi over 4. So it would be 1, 2, 3, 4, 5 right there. Anyway, that's just being familiar with this. It's the one thing that as I go through the read-ins and homeworks, just quickly knowing those angles and those X, Y coordinates. So feel free to challenge yourself to do something similar, where rather than just looking at these images that show all the numbers, sort of think about where they came from, or maybe even make your own. I don't care if you don't simplify and you just keep these as pi over 6, 2 pi over 6, 3 pi over 6, and so on. It's fine with me. The only other thing I wanted to talk about on this video is that I will log into the Zoom meetings. I'm going to do one more new share, go back to the WOMAT page. And so I'm just doing this to show you that always here, you know, pretty near the top, I'll have this Zoom link for meeting with Paul. Clicking here or clicking here will open Zoom. And just point out to you that at these office hours right here, I will log into Zoom and turn it on. So I had forgotten to do that. It's been a while since I taught an online class, but I have had students popping in online to those office hours. So I just wanted to highlight those, but then also say if those times don't work for you, you can always reach out and request a time to meet, especially on Fridays. I've got lots of time on Fridays. Anyway, hope you're all doing well, and reach out. Maybe you just want to say hi. I just kind of want to meet my teacher, so we can just talk for a few minutes. Anyway, have a good one.